too much fun. 3, 2, 1.
Hi, so I'm Maggie and this is Sachin. We also have Sarah in our group. So today we're at the Indigenous Student Center here at McMaster, and we're using a lacrosse stick, which is a traditional Haudenosaunee game. So we're going to use this to demonstrate projectile motion and also an inelastic collision against the wall.
3, 2, 1.
So since it's projectile motion, we can take a few of the values that we measured / estimated from our experiment and calculate the velocity right before the ball hits the wall. So if we assume the ball has a mass of 0.5 kilograms, and from our video we calculated that the time from when the lacrosse stick releases the ball and to when it hits the wall is 0.25 seconds. We have a acceleration in the x direction of 0 if we don't take into account air resistance, and then our acceleration in the y direction is just due to gravity, so it's negative 9.8. If we assume that the theta here is 45, which we kind of saw from the video, then we want to figure out the velocity right before we hit the wall. So our displacement in this direction is in the x direction we calculated to be 1.2 meters. We measured it. So the displacement equals the initial x velocity times time. So our initial velocity we can calculate to be 1.2 meters over, we calculated from the video 0.25 seconds, which is 4.8 meters per second. And then seeing as, because theta is 45, we know that the velocity in the y direction is the same as the velocity in the x direction, so it's also 4.8 meters per second. So then we can calculate, so we know the velocity in the x direction right before it hits the wall is 4.8 meters per second. And then due to gravity, the velocity in the y direction decreases. So then we can calculate the final y velocity right before it hits the wall. So it would be, so the final velocity equals the initial velocity plus the acceleration times time. So that would be 4.8 plus negative 9.8.
Okay. So we're assuming that the collision is perfectly elastic, which means that the kinetic energy is conserved as well as the momentum. So that means that in the horizontal direction, the velocity is exactly the same before and after the collision, and just in the opposite direction. And for the vertical velocity, it's exactly the same.
Yeah.
So in order to calculate the vertical displacement of the ball, so the height at which the ball hits the wall, we know the initial velocity and we know the final velocity and we know the time, so we can calculate displacement equals v0 plus v final over 2 times time. So we know that v0 is 4.8 meters per second plus our v final, which is 2.35 meters per second over 2, and all of that is multiplied by our time, which is 0.25 seconds. And then we calculate that out to be 0.89 meters. So that's the vertical displacement that it's traveled up the wall.
Yeah.
Okay. So we're assuming that the collision is perfectly elastic, which means that the kinetic energy is conserved as well as the momentum. So that means that in the horizontal direction, the velocity is exactly the same before and after the collision, and just in the opposite direction. And for the vertical velocity, it's exactly the same.